Okay. Is it visible now?
Yeah.
Okay, my study, basically it is the advancement of formative assessment. Like during the classes, we know that students have different problems, and we help them to solve those
Sorry
issues.
to interrupt. Would you please make it slideshow and then we can see clearly?
Okay, sorry.
Okay, that's perfect. Thank you.
Basically, this study was planned during the online teaching, because when we teach students during the classes, we help them to solve their problems. But when it goes to the online, and I felt a need that I should study that which type of common mistakes students are doing during the solving linear equations. So topic of my study is analysis of common errors in solving linear equations, diagnostic assessment. My plan of presentation is like introduction, and this is my methodology, data analysis, conclusions, and recommendations. So while starting, before finalizing or before planning my research, the perception was that solving linear equations made a tough area for the students in learning mathematics. And literature has three main errors are found, that while students made three errors while solving linear equations during their classes. That was implicit multiplication, treated as addition error. It was noted by Booth, and she said that referred it as a conjoined error. And Karen also has some examples of, and she said that she denoted it as a deletion error, like while simplifying equations. For example, 39x minus 4 to 35x, like they are ignoring the variables. And 2yz minus 2y, they said that it is that was taken from their studies. And the second error they made was errors with the brackets, and this was previously known or identified by the Kuchman's study. And they gave an expression to the students like 4 into n minus 5, n plus 5, or 4n plus 20, and found that 17% of grade 10 students were correct only, while 19% respondents incorrectly by multiplying 4 to n only, and refused to, and like they are not answering it to the like 4 is not multiplied with the 5, or they can give the answer, they are giving the answer 4 into n plus 5. Megger and Stacy also found given the same type of responses to the students, and found that only 47% of the year 10 students were correct, and 14% and 11% for year 7 and 10 admitted this type of errors, but 21% and 22% for year 8 and 9 who omitted the brackets. So they try to multiply with the same procedure. The third is nearest integer error. Stacy and Mega and Stanley and Trice also define the error nearest integer with the three types of errors: the trial and error, random, sequential, guess, check, and improve. And in these, they study like students go to the nearest integer. Like if the answer is 1.8, they said that the answer is 2. Or if the answer like 1.34, they said that 0.7, or they omit the decimal part. So after going this, what happened to it? This plan of the study was, the objective of the study was to analyze the common incorrect responses to the given task to determine common procedural errors of the students. The methodology used is this secondary school students offered an online test. They were 1209 who has responded. There were many, but they have omitted, they left blank, they give incomplete responses. Only 1209 students responded. on two sets of 11 equations. Like in first set there were four equations, and in second set there were seven equations with one or two variables on one side or both sides, and only the incorrect responses of the students were under consideration and to determine the common procedural errors, and data was collected through the Excel sheets. This is an accuracy table for 11 tasks involving linear equations. It was given to the students. The labels to the equations or questions were assigned, and the answer solutions are given, correct or incorrect, and blank responses. Like it also shows that when students go at the end to the test, the blanks are more than as compared to the correct responses or the incorrect responses. Data analysis. By analyzing the incorrect responses, it was come that 44 common errors, 4 errors for each of 11 tasks, 44 common errors on these 7 equations, and by 1209 students. This analysis identified 6 common procedural errors from the set of 44 common errors. Codes were assigned to each of the 6. 6 were more common common procedural errors in the Excel file only if these responses had already been identified in the top four errors. That I studied to see the pattern which type of error students are. If one student is making error on one equation, that either they are making the same error for solving the linear equation in the second screen or on other some other given in the instrument results and discussions. On the basis of responses analysis, 7 groups were found. Was correct response, students who left the blank, breakdown of incorrect responses in top 4 errors, miscellaneous errors. 20 of the 44 common errors were coded with the one of the 6 common procedural errors code: IMAS, MCO, VES, NIS, RES, and AES. The detail is like this type of common errors were found in students' responses. Implicit multiplication addition solution. For example, students who regarded 4n as 4 plus n, treating the implicit multiplication as addition. MCO is manipulating constants only. For example, 4n plus 9 is equal to 37. They put 4 9 is equal to 4 n is equal to 28, and they do not manipulate. They manipulate constant only, and they do not go for the further solutions. Nearest integer solution. For example, 8a plus 5 is equal to 3a plus 14, like variables on both sides. So the answer, they will give the answer of 2 when it was 1.8. Bracketless equation solutions. For example, 4 into n minus 3 is equal to 21. Students give 4n minus 3 is equal to 21. They ignore the brackets, or they omit the brackets. Reverse equation solution. For this, they inverse the order of the terms in the equation. 14 minus 2 is equal to 8. The students give the solution 11, which is possible when 8 is equal to 2a minus 14. So they try to write the equation in a reverse order, and they get wrong answer. AES is addition equation solution. For 4a minus 7 is equal to, for example, like they ignore the sign of the constant, and they transfer it or move towards the other side with incorrect subtraction, or without knowing the correct operation. There are some students who on like we find combination of errors on some equations. It was found some incorrect responses with the combination. Like question 8, the task was 6 minus 5a is equal to, the student submitted two type of errors: reverse equation and nearest integer equation. For question 2, 4n minus 3 is 4 into n minus 3 is equal to 21. They have like bracketless error and addition equation. Similarly, we have found this type of common errors while solving the linear equations. Some errors were found which were not detected. Like previously, it was found in their responses, but while conducting this study, these errors were not found. Like they ignore the constant on right hand side. uh, 5n minus 2 is equal to 3n plus 6. The alternate equation, like they ignore the constant on right hand side. The right answer is 5n minus 2 is equal to 3n. And for question 4, it is 12 plus 2 is equal to 8n plus 15. And they wrote that 12n plus 2 is equal to 8n. And subtraction equation and order operations, they ignore unknown right terms on right hand side. First they ignore the constants, and here they ignore the unknowns. Left hand side when unknown is equal to 1, and left hand side when n is equals to 14. Conclusion. The analysis of common errors confirmed the existence of three errors which we have found found in the literature. Students providing the solution of related but different equations where the implicit multiplication has been replaced by addition. Students giving nearest integer solution as an indication of a limited strategy such as substitution, and students not expanding brackets correctly. The analysis of common errors also revealed three unexpected common procedural errors, like students manipulating constants only, students providing the addition equation solutions, and students providing the reverse equation solutions. So then, on the basis of conclusion, it is recommended to the curriculum developer, textbook writers, and teacher training institutions. So to look at the text and examples, it will need to be self-explanatory, or to avoid such type of errors, or the teachers need to be have a workshops or in-service training to take care of the such errors of the students. Thank you.